Okay, let's dive into programming your brain for absolute efficiency. Welcome to this explainer, where we are going to conquer Cambridge IGCSE computer science questions, specifically focusing on automated and emerging technologies. If you're preparing for syllabus 0478, you already know this section can be an absolute minefield. I see this every single year. You've got students like Alex, who overloads their answers with raw computer science facts but provides zero actual analysis. And then you have students like Sam, who rushes through the paper, completely missing the command word requirements and throwing away easy marks. It's incredibly easy to drop grade boundaries by giving vague, generic answers. But today, we're acting as your ultimate strategist. We are going to look at exactly what the examiner wants to see, extracting the precise frameworks from the source material to guarantee you hit those top marking bands every single time. Let's get into it. Here's our battle plan for today. We'll start with the tech trio defined, move into inside automated systems, map out the anatomy of robotics, break down artificial intelligence, see expert systems in action, and finally bring it all together with exam mastery, high-level answers. Section 1, the tech trio defined. We're going to begin by clearly separating three concepts that students constantly mix up on their exam papers. It is absolutely crucial that you have a crystal clear boundary in your mind between automated systems, robotics, and artificial intelligence. So, starting with automated systems, the main takeaway here is that these systems run entirely on their own. By definition, they're a combination of hardware and software designed and programmed to work automatically without any human intervention whatsoever. Think of a nuclear power station's distributed control system. It's this massive, powerful computer network monitoring temperature, pressure, and radiation levels 24/7, ready to automatically shut down processes if parameters are exceeded. No human hand pulls a lever, the system does it. Or think about something simpler, like adaptive cruise control in a car. It pulses infrared lasers to measure the exact distance to the vehicle ahead, automatically adjusting the brakes or accelerator. Again, no human input is required for that specific automated task. Now, every single high-level exam answer you write about automation absolutely must demonstrate this fundamental concept, the core automation loop. It's essentially a dumb automatic cycle. Step 1, sensors capture data from the environment. Step 2, the microprocessor takes that incoming data and compares it against stored parameters. Step 3, if action is required based on that comparison, the microprocessor sends a signal to the actuators, which execute the physical changes, like opening a valve, sounding an alarm, or engaging a brake. If you mastered this three-step loop, you literally have the master key to almost any automated systems question they can throw at you. Let's move to a real-world example that frequently pops up in the 0478 syllabus to see how this builds in practice. Have you ever wondered how an autonomous train manages to safely load and unload passengers without human conductors checking the doors? How does it know not to crush someone? The automated train door perfectly illustrates our core loop in action. Look at this setup. You have sensors above the doors to detect the presence of passengers waiting to board. But more importantly, you have pressure sensors between the doors themselves to ensure no one is trapped. Now, these sensors are constantly streaming data back to a central microprocessor. The microprocessor evaluates this data against its pre-programmed rules to determine if it is safe. Only when the coast is completely clear does the microprocessor send a signal to the actuators, which then physically operate the door motors to close them safely.
And this brings us to the examiner's lens, which is where students like Alex and Sam always lose marks. A typical low-level answer, the kind Sam might write when rushing, says, when someone is in the way, the sensor tells the actuator to open the door. No, never ever say sensors talk directly to actuators. Sensors are completely dumb data gatherers. They just constantly send raw data to the microprocessor. It is the microprocessor, the true brain of the operation, that makes the decision and sends the signal to the actuator. Furthermore, sensors don't just send data when something happens. They send it constantly. Remembering the word constantly will instantly elevate your answer. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 3, the anatomy of robotics. Building on that core automation loop, let's inject some physical movement and look at true robotics. You see, not every automated system is a robot. To get full marks when defining a robot in your exam, you must explicitly mention three defining characteristics. First, it needs the ability to sense its surroundings. It uses sensors or cameras to build up a 3D map of size, shape, or weight. Second, it must possess a degree of physical movement. We are talking about actual mechanical parts: wheels, cogs, pistons, gears, and end effectors. End effectors are those specialized attachments at the end of a robotic arm that actually carry out the tasks, like a gripper or a welding torch.
Finally, it must be programmable. It needs a controller, essentially a microprocessor system that dictates its actions and can be updated or reprogrammed for totally different tasks.
Now, you have to be super careful with exam trick questions here. You'll often hear the term software robots or bots. These are programs like web crawlers that endlessly roam the internet, scanning and categorizing websites for search engines, or chatbots that pop up on banking websites to answer your questions. But listen closely, according to the strict Cambridge syllabus definition, because they completely lack physical movement and mechanical structures, they are not technically true robots. Keep that distinction incredibly sharp in your mind. You also need to distinguish between the two distinct classifications of physical robots, independent versus dependent. Independent robots are completely autonomous. They require absolutely zero direct human control and can totally replace human activity for a given task, like a warehouse robot navigating a maze of shelves all by itself. Dependent robots, on the other hand, require a human interface, like a control panel or a joystick. They are designed to supplement and assist human activity, rather than replace it entirely. When the exam asks you to evaluate robotics, you need solid, contextualized, real-world examples. In agriculture, robots are revolutionizing phenotyping, which is observing plant health, and executing highly precise weed control without soaking the field in chemicals. In medicine, we're seeing incredible advancements, like microbots used in target therapy to deliver drugs directly to a tumor, reducing damage to surrounding healthy tissues, or robotic arms used by surgeons for remote, ultra-precise procedures. And in industry, robots with specialized end effectors can weld car bodies 24/7 without ever taking a break. But a top-tier student always balances their exam and answers. For every advantage, have a disadvantage ready. Mention the massive initial setup costs, the severe risks of cyber vulnerabilities and hacking, and the societal impact of workforce de-skilling. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, moving into Section 4, Artificial Intelligence Explained. We are stepping beyond basic physical movement and exploring the simulation of intelligent human behavior. At its core, AI is essentially a massive collection of rules and data paired with the ability to reason, learn, and adapt to external stimuli. It is trying to replicate human cognitive functions. The examiners will expect you to clearly differentiate between the 3 categories in the AI hierarchy. First is narrow AI. This is where a machine performs one single, specific task with superior performance to a human, like a chessbot that can beat a grandmaster but literally cannot do anything else. Then there's general AI, where a machine performs a specific task at a level similar to a human. And finally, the holy grail, strong AI, where a machine demonstrates superior performance to humans across many different complex tasks. Section 5, Expert Systems in Action. This is one of the most highly testable forms of AI on your 0478 syllabus. Expert systems are applications specifically designed to mimic the knowledge, experience, and inference of human experts in complex fields like medical diagnosis, tax calculations, or even geological oil prospecting. Now, I want you to treat this diagram like a data scan challenge. This architecture right here is an absolute goldmine for marks. If you're asked to describe an expert system, this is the exact mental structure you need to visualize. It breaks down perfectly how the system processes a human query to produce a logical diagnostic. Notice the 4 distinct, separate components: the user interface, the inference engine, the knowledge base, and the rules base. Let's break down exactly how they talk to each other. The flow is always exactly the same, and you need to memorize this. First, the user interacts with the system via the user interface, usually answering questions through dialog boxes and prompts. Second, that input goes to the inference engine. Think of the inference engine as a brilliant detective. It's the main processing element, a problem-solving search engine. It takes the user's clues and cross-references them. Where does it look? It looks in the knowledge base, which is like a massive library, a repository of stored facts and data points provided by human experts. But it doesn't just blindly match words. It applies the rules base, which is a strict set of logical inference rules, to draw accurate conclusions from those facts. Define the inference engine, knowledge base, and rules base accurately, and you're securing maximum points. Before we move on to our final exam application, there's a huge flaw I see in so many student answers:
confusing AI with machine learning. They are not interchangeable buzzwords. Remember that artificial intelligence is the broad, overarching umbrella term for simulating human cognition. Machine learning, on the other hand, is a specific, narrower subset of AI. It is specifically where algorithms are actively trained to learn from past experiences and massive datasets, allowing them to make predictions based on previous scenarios without being explicitly programmed for every single outcome. Machine learning analyzes volumes of complex data that would literally take humans lifetimes to process.
Section 6. Exam Mastery. High-level answers. All right, this is where we tie all of these technological pillars together. We've covered the core theory, but how does this actually translate into top grades? Let's look at exactly what a top-tier student response looks like in the wild.
Imagine you open your exam paper and you're presented with this exact scenario: a complex, automated irrigation system used on a massive farm in Brazil. The command word asks you to evaluate its advantages and explain the control loop. You have 60 seconds to plan your paragraph. How do you avoid writing a generic, low-level answer that barely scratches the surface?
The ultimate key takeaway here is context. A low-level answer, the kind that gets heavily penalized, relies on generic, memorized facts that could apply to a toaster just as easily as a farm. They might say, it's safer, it stops fields becoming dry, and it saves money. The examiner is going to award almost 0 marks for that because there's no analysis. Now look at the high-level model answer. It explicitly uses the context provided in the scenario. It mentions the vast areas of the Brazilian farms leading directly to reduced labor costs. It specifically names the ultrasonic water level sensors shown in the diagram. It points out the data is sent via wireless transmission because of the immense physical scale of the fields. And instead of just saying it saves water, it elevates the point to precise control of scarce water resources. Context is absolutely king.
So let's synthesize this into your ultimate computer science success blueprint. If you follow this automated 4-step blueprint for every single system question you face, you will consistently hit the top marking bands. Number 1, never just say sensor. Specify the exact sensor name based on the scenario. Is it ultrasonic, pressure, infrared? Number 2, explicitly state that sensors constantly send data to the microprocessor. Number 3, always detail that the microprocessor compares this incoming data against stored parameters. And number 4, contextualize every single advantage and disadvantage to the exact scenario they gave you in the prompt. Do not be generic.
Think about how you can apply this core concept to application loop in your own studying. You now fully understand the mechanisms of automated systems, the defining traits of robotics, the logic of expert systems, and exactly how the examiner wants you to articulate them. I challenge you to pull out a past paper right now and rewrite one of your old answers using this exact 4-step blueprint today. Program yourself for success. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams IGCSE, to excel in your Cambridge examinations. Subscribe right now to Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Finally, drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.